Hello everyone, welcome back to my channel. Now we are going to start off with the course on MCQs on electrical machines. Starting off with question. The ideal value of voltage regulation of a device is. So the answer is B, that is 0, as it means that there is no change in no load voltage to full load voltage. So it should be minimum. Next. In which of the following generators negative voltage regulation can occur? So the answer is in both B and C, that is series generators and overcompound generators. We know that we have high rising voltage characteristics. In both the cases, the terminal voltage rises when the load increases due to series field characteristics. Therefore, these two have negative voltage regulation and are not suitable for ordinary power supplies. Next, essential condition for two DC generators are connecting for parallel operation is or are. So the answer is it is terminal voltage should be same, that is A. We know that in most essential, this is the most essential condition. Next, a shunt generator is running at 1000 rpm. If the flux is reduced by half, then what is the new speed? So by this formula we know that EB is equal to phi Zn by 60 into P by A. So here N is directly proportional to 1 by flux, or say N is inversely proportional to flux. For this equation, if all other remains constant, the speed will be inversely proportional to flux. So it is reduced by half. Then the speed will increase to double. So the answer will be B, that is 2000. Next, a DC 4-pole lap wound generator is running at 1000 rpm, having 1200 conductors and flux density is 10 milliweber. Find the generated EMF. So from this formula, phi Zn by 60 into P by A, we can just put the value, that is 1000 rpm is the speed, 4 poles, 1200 conductors and flux density is 10 milliweber. So the answer will be 200 volts, that is C. Next, maximum power will be developed when the back EMF is. So the answer is it is half. So half of the supply voltage. Next, in DC motors under leading pole tips, the flux density will. So the answer is it will increase, as we know that main field flux and the armature flux will aid each other under the leading pole tips. For the motors, it will oppose each other in the trailing pole tips. Next, in DC motor under the trailing pole tips, the flux density will. So the answer is it will decrease. We know that for the DC motor, main field flux and the armature flux will oppose each other under trailing pole tips. When armature flux leaves the main pole, it opposes the main field flux. Next, in DC machine, torque is proportional to which of the following? So the answer is it is proportional to flux as well as armature current. Next, hysteresis loop represents the area of. So the answer is it represents the hysteresis loss. That is C. Next, which motor cannot be started on no load? So the answer is it is series motor that cannot be started on no load. DC series motor cannot be started as it will attain a dangerously high speed and damage itself. Armature winding will not burn, but it will open from the axis due to centrifugal forces. Next, which of the following motor has a negative speed regulation? So the answer is it is differential compound motors which has negative speed regulation. We know that the flux will reduce as the load increases because series flux opposes the shunt field flux. So this will increase the speed. Hence it has a negative speed regulation. Next, armature resistance control method is used for below rated speed values, we know that in armature circuit resistance method, the armature resistance is increased. As a result, the back EMF decreases, and as the speed is directly proportional to the back EMF, the speed will also decrease. Next, a generator without commutator is, so the answer it is a AC generator. Next, armature reaction effect is more in which of the following methods? So the answer is it is more in field weakening method. We know that in field weakening method we are reducing the working flux to increase the speed. Therefore, the effect of armature flux on the main field flux or the armature flux will increase in case of field weakening method. Next, field weakening method is also called as constant power control method. As we know that the field flux control method is a constant power drive. In this method, the speed is controlled by varying the field current. So the power remains constant for a given speed range. This is the formula. P is equal to EB into IA. Next, armature resistance control method is also called as. So the answer is it is known as constant torque control. Armature resistance control method. The motor shaft torque becomes constant given over a speed range. Next, if the terminal voltage of 1000 rpm shunt motor is reduced to half, the speed of the motor will be. So the answer it will be 1000 rpm. We know that N is directly proportional to EB by phi. So EB can be written as Vt minus Ia by R into divide by phi, and that is proportional to Vt by phi. So if the voltage is reduced to half, then the flux will also be reduced to half because the current flowing through the shunt field is also halved. So the speed remains same. Next, diverters are used only in, so the answer is it is used in series motor. As we know, for the speed control, these are not used in shunt motors. Since shunt field winding resistance is very high, so if we connect a diverter across a shunt field winding, the total current will flow through the diverter and almost short circuit the shunt field winding. And this will in turn increase the motor speed at very high value. Next, which of the following starter is sufficient to start the DC series motor? So the answer is it is 2-point starter. Okay, so if you like my videos, you can also subscribe to my channel, and if you have any doubt, you can always ask me in the comment section below. Thank you.